today's class, Ace Math with Joy. All right, now a lot of you must have seen a bridge. You must have passed through a bridge. Even if you've not seen a crane, you must have seen a bridge, right? Now a bridge does not move, it's not moving, it's static. Is that correct? Now, have you ever wondered how several forces act on that bridge without moving? So today we're going to be looking at how to combine these forces into a single force, and as well as see how to split one force into different directions. So join me in today's class as we look at coplanar forces, its composition as well as its resolution. If you are yet to like, share or subscribe to this channel, please do yourself that favor. All right, now before we progress, you must have known before now that a force is simply a push or a pull. So having known that a force is a push or a pull, what is coplanar forces? That's the next question. What is coplanar forces? So simply put, these are forces whose lines of action lie in the same plane. These are forces whose line of action lie in the same plane. Okay, now let me give you an instance. If you look at forces acting on a body on a flat surface, okay, you see, imagine a body that is on a flat surface, is not acting downwards, is not, So now how do we resolve or talk about forces acting on that body when it is on a plane? That is coplanar forces. Okay, so now under this topic, like we said, we're going to be looking at both the composition and the resolution. So in the composition of forces, we are looking at how to combine two or more forces to obtain a resultant force. While in the resolution, we're going to be splitting one force into two or more components, usually along perpendicular directions. I hope you know what I mean perpendicular. That is on the x and y components. Are you getting it? Are you seeing the difference now? So in composition, we are combining forces to obtain the resultant, while in the resolution, we are splitting forces into the x and y just to get the what? The components in both the x and y directions. So moving forward very quickly, let's look at composition. Okay, so having known what composition is, we said we're going to be combining concurrent forces into a single force. We can either use the graphical method or the analytical method, okay? So now if two forces are acting in the same direction, let's say I have force P here, and then I have force Q here, acting in the same direction. What happens to the resultant? Of course, it will also act in the same direction. So how do we get the resultant? The resultant simply becomes P plus Q. Why? Because they are acting in the same direction. So what happens when they are acting in different directions? When they are acting in different directions, let's say we have force P acting in this direction, and then let's say we have force Q acting in this direction. So the resultant becomes P minus, so we subtract when the forces are acting in different directions, and then we add when the forces are acting in the same direction. Now, what happens if P and Q, these two forces P and Q, act at an angle called theta? You see, when we just looked at like the scenario painted here, there's no angle in view. We just have two forces P and Q. Either they are acting in the same direction or they are acting in different directions. So what happens to their resultant? We've simply seen what to do. The same direction, add to get the resultant. In different directions, subtract to get the what? The resultant. So what happens to the resultant? The resultant will either follow the direction of P or follow the direction of Q. Okay, now if P and Q act at an angle theta, that is when we bring in the parallelogram law of forces. The parallelogram law of forces. Okay, now let's look at what happens. Now we have force P going this way, and then we have force Q going this way. So since we called it the parallelogram, so let's complete the other side or dimension. I want to use broken line. Okay, so now this remains our force P while this remains our force Q. So now this is the resultant going in the same direction with what? With P and Q, right? Okay, so this is it. Now the force between these two forces, let's have B, okay. Then let's say that here is C and then here is D, right? Okay, so you're going to know why I had to complete that side. Okay, we're going to be using it. It's very important. Okay, so now what is this angle going to be? Let's quickly talk about it. This is going to be what? Theta. And I hope you know why. Here is theta. So this is going to be theta. You know why? You know why? This is angles on what? On a straight line. So if here is 180 minus theta, automatically this angle is going to be theta. So that when you sum them up, it gives you 180. Okay, now back to the business. How do we find the resultant of this using the parallelogram law of vector, given that an angle theta is between the forces P and Q? So now if that happens, look at what's going to happen. If we let's bring out one of the sides of the parallelogram so that we can easily see what we are doing clearly. So now here we have 180 minus theta, and this 180 minus theta is the angle facing the side we are looking for, which is the resultant. Is that correct? Now on this we have an angle alpha, right, with Q on this side and then O on this side. We have B here and then we have D here. So here is our P. So now to find the resultant using this parallelogram law of vectors, before we move on, I don't want to use this 180 minus theta. It's going to look complex. So let 180, you can actually use it that way anyway, minus theta be equal to beta. Okay, I want to use just something singular. So that we'll have R it will be equal to the square root, the resultant to be square root of P squared plus Q squared minus 2PQ cos beta. You know what beta stands for, right? Good. Okay, now 180 minus theta, we all know, if you know your angles very well, we all know that 180 minus theta is not an acute angle. You know that theta is an acute angle, right? Acute angles are angles that lie between 0 and 90, right? Okay, so angles that lie between, let's say 40. If you remove 40 from 180, for instance, you have what? An obtuse angle. So just note that beta is always what? Obtuse, right? So if beta is an obtuse angle, that means it lies between what? 90 and 180. It means it is in the second quadrant. And if you have done your sine and cosine rule very well, or even if you've not gotten to that, if you have done your trigonometry very well, you would know that according to acts, that in the second quadrant, cosine is negative, right? So if cosine is negative in the second quadrant, that means this cos beta is going to be minus cos beta and it will affect this sign. Okay, so that means that the resultant force becomes the root of P squared plus Q squared plus 2PQ cos beta. So why is it important you understand this very well? So that you won't be wondering, why is it that we are using cosine rule? Meanwhile, the cosine rule says minus 2P cos beta. So why are we saying plus? So you've seen the reason. Okay, now having seen the resultant, the next question is, what happens to the direction? Okay, So know that you know that force is a vector quantity, right? So what makes it vector? Magnitude, direction. So the resultant force talks about the magnitude. So what about the direction? That was the reason why we had to complete this. So I will really need this. I think I'll have to repeat it because I will have to be looking at it. We have to look at it together. Now, having redrawn this, because I want, like I said earlier, I want us to be seeing this drawing while we do what we do. All right, we have gotten the what? The magnitude. Now it's time to find the direction. So now what happens here? Now to find the direction, look at this. I'm going to pick out this triangle OCD. I have O, I have C, and then I have D. So if you look at this triangle OCD, you will see that the angle here is alpha. This is our resultant. We have our Q here. Okay, what we have here is not Q. What we have here is actually Q and BD. So let's just leave it like that. Okay, now to find this, since we are looking for direction, what do you think we're going to have? We're going to have what? Tan, right? Okay, so now we'll have tan alpha to be equal to opposite over adjacent. Okay, so now how do we find CD? That's the next question. Now look at that triangle BCD. Let's pick it. Triangle BCD. So if we pick triangle BCD, we'll have theta here. Okay, so we have our P here. Okay, so now we have B here, and then we have D, we have C. Right? Okay. So now since here is theta, if I want to find CD, you know that here is opposite and then here is what? Adjacent. So if I want to find CD, since it is opposite, I will have sine theta to be equal to CD over P. So since I'm looking for CD, if I cross multiply, I have CD to be equal to P sine theta. So that's how I get my CD to be P sine theta. So coming to OD, OD is equal to OB plus BD. So I already know my OB to be what? To be Q. So the question is, what is BD? Now looking at BD, BD is the adjacent side here. So we have cos theta to be equal to BD over P. So cross multiplying, BD is equal to what? P cos theta. So now going back, I have my tan alpha to be equal to P sine theta over Q plus P sine theta. As simple as A, B, C. Okay, so even if you are forgetting the formula, if you remember how it was gotten, you will not forget it. Now let's quickly look at resolution of forces. Okay, so in resolution of forces, it's very important to pay attention to this part. In resolution of forces, we are always interested in the what? In the angle that the resultant force makes with the horizontal. Pay attention. The angle that the resultant force makes with what? The horizontal. So pay attention to that. So now on my coordinate or on my plane, this is my vertical force. So let me call this Fy. This is my horizontal force. So let me call it what? Fx. Now, if this is the resultant, so my interest is on the what? On the angle theta, which is the angle that this resultant force makes with the horizontal. So if this is my Fy, this is also my Fy. So the reason why I'm putting this here is so that we can easily relate and resolve, right? So now for the horizontal component, For the horizontal component, you see that theta is adjacent. So since in resolution of forces, since we are interested in the angle that the resultant makes with the horizontal, anytime you are resolving force on the horizontal, just know that it's cos theta. Are you getting what I'm saying? So anytime you are resolving force on the horizontal, just know that it is what? Cos theta. Finish. So what do we have? We have cos theta to be equal to adjacent, which is fx over hypotenuse. Okay, so fx is equal to what? F cos theta. So if that is the case for the horizontal, it means that for the vertical component, we will have sine theta to be equal to Fy over F. So Fy is equal to F sine theta. So you have resolved your what? Force on the horizontal and on the vertical. But there's something very important you also need to take note of. And what is that? You need to take note of the direction or the inclination of the force under consideration while you are what? While you are finding the component of a force. So what does that mean? Now for this force resolved, you will discover that the angle of inclination is made on the positive x-axis. So what happens if it is on the negative x-axis? So if it's on the negative x-axis, everything being equal, this is still our Fy, and then here we still have our Fx. Y here is theta, the angle made, the resultant makes with the horizontal. So now if we are now resolving force here, the only difference is that since it's on the negative x-axis, when resolving on the horizontal component, we are going to have cos theta to be equal to minus Fx over F. So cross multiplying, we have minus Fx to be equal to F cos theta. So since we are looking for force on the horizontal and not the negative force, what we'll now have is dividing both sides by -1 or multiplying both sides by -1. We'll have Fx to be equal to minus F cos theta. So if we also have it on if you also have it here on the negative y-axis, remember it is still the angle made with the horizontal, so we still have our theta here. So what happens? Okay, so since on the negative y-axis, our horizontal force don't have any issue. Our issue becomes with the vertical. So what happens? Just the same thing that happened in the first one. So sine theta becomes minus Fy over F. That's just the only difference, right? So your F in the vertical component becomes minus F sine theta. So now somebody might be asking, what happens when x and y are negative? That is if it were to be on this side, right? Okay, so this remains the force on the horizontal, the force on the vertical, the angle made with the resultant and the horizontal force. So when we resolve, we have okay, let's start with the horizontal. So we have cos theta to be equal to minus over, so both of them are going to be what? Negative. That's okay. So now we're going to solve this question together. So the question says 3 coplanar forces of 10 Newton, 15 Newton, and 20 Newton act at a point. The 10 Newton force acts horizontally to the right. The 15 Newton force acts at 60 degrees above the horizontal, and the 20 Newton force acts vertically downwards. We are to find both the magnitude and direction of the resultant. Now, why do I like this question? Why I like this question is that it is in word form. There's no diagram, all right? So now what do you do? The first thing to do is not to start resolving, no. The first thing to do is to have a sketch so that you will know where each force is, so that you will know what you are resolving. Is the force up above the horizontal? Is it below? Is it on the negative y? So that you will know what you are resolving. Okay, so let's go. So now we're going to be taking the statements one after the other so that we can resolve accurately. So now the first thing they said in this question is that, okay, so let me draw my plane first. Then we interpret one after the other. So now the 10 Newton force acts horizontally to the right. So this is where it is. Okay, so I have my 10 Newton here. Okay. Okay, so the 15 Newton force acts at 60 degrees above the horizontal. Okay. The 15 Newton force acts at 60 degrees above the horizontal. So that means it is here. So I have 15 Newton here, and then I have 60 degrees here above the horizontal, right? Okay. Then the next one, the 20 Newton force acts vertically downwards. So for it to act vertically downwards, it means it is here, 20 Newton. Okay, so now having known this, you see it is very easy for us to now start resolving. So now to resolve, I'm going to draw a table. Let me draw a table by the side. So I have my forces. So the first one, I'm going to be resolving in the x component and in the y component. Okay, so now the first force, we have 10 Newton, right? I love this question so much because it will help you so well. Now, if you look at the 10 Newton force, you will see that it forms a right angle, right? Now, let me pick it out so that you understand. So now where the resultant is exactly on the x-axis. Okay, so if the resultant is exactly on the x-axis, remember that we said that in resolution of forces, we are interested in the what? The angle that the resultant makes with the what? The horizontal. So if the resultant force is exactly on the x-axis, what does that tell you? It tells you that the angle the resultant makes with the horizontal is 0. So resolving on the x-axis, we're going to have 10 cos 0, and cos 0 is 1, so we still have 10 here, equal to 10. So if we resolve it on the vertical, we're going to have 10 sine 0, and sine 0 is what? 0. So we have the force on the y component to be 0. So now coming to force 15 Newton. Okay, so now this one, look at this one now. So the resultant that this one makes, since our resultant is here, you can decide to use 30, which is the what? The complementary, right? So that you understand it better, you can decide to do it this way. But then if you are using 30, that means it will be sine, on the x-axis you will have sine 30. But if you're using 60, on the x-axis you have cos 60. Okay, so I just want to let you know you can use the complementary. So we have 15 cos 60, and 15 cos 60 is 17.5. I hope you are pressing it with me. Okay, then here we have 15 sine 60, which is 12.99. Okay, then for the last one, we have 20 Newton. So now this 20 Newton, this is another place where we need to pay attention, right? Okay, now why do we need to pay attention here? Remember that this 20 Newton, it shows you, what does it tell us? It tells us that the resultant is exactly on the y-axis. The resultant is exactly on the y-axis, which is different from what we have already known, the convenient information we already have, that the resultant angle is the resultant, the angle is always between the resultant and the x-axis. So on this note, the resultant is exactly on the y-axis. So if it's exactly on the y-axis, what happens? Two things. Either you decide to resolve that way on the y-axis, just like you've been doing for x. Do you understand? So if you decide to do it that way, that means you're going to have 20 cos 0, or you find the complementary, that's if you want to go ahead and resolve on the x. So doing that, what you will now have will be 20 cos 90. That's on the x-axis. That's if you must. Do you understand what I'm saying? Good. So 20 cos 0 here, and then 20 sine 0. Okay, and sine 0 is 0. Then cos 0 is what? Now note, remember something. I forgot to put my minus here. Now, why am I putting minus? Because it is on the negative y-axis. Remember I said you should take note of the direction or inclination of the force under consideration while finding the component of a force. Remember that. So since this is on the negative y-axis, we'll have minus 20 cos 0. And cos 0 is 1. So I have minus 20 Newton. Okay, so now I'm going to sum the forces so that I can get the resultant force. So summing the forces together, I have 10 plus 17.5. Okay, sorry, this should be 7.5. So 10 plus 7.5, I have 17.5 Newton. And then I have 12.99 minus 20. So that will give me minus 7.01 Newton. Okay, so now having gotten summation of my forces, I have the resultant, which is equal to the square root of summation of forces in the x component squared plus summation of forces in the y component squared. And that will give us 17.5 squared plus minus 7.01 squared. Okay, so that means the resultant is going to be, if you square this and then take the square root, you're going to have 18.85 Newton. So what is this? This is the magnitude. So to find the direction, remember what we said, to find the direction, we're going to have tan alpha to be equal to sum of forces, okay, in the y component over sum of forces in the x component. Okay, now, so if you look at sum of forces in the y component, we have minus 7.01 over 17.5. Now, what does that minus 7.01 tell us? It tells us that the direction is what? Below the x-axis. That is it. It is below the x-axis. So we're looking for direction below the x-axis. Okay, so we'll have alpha to be the tan inverse. So when we divide, we're going to have 0.4006. So our alpha is 21 when you check with your table or your calculator, approximately 21.8 degrees. So what is the direction? Since the y component is negative, we have The resultant acts 21.8 degrees below the horizontal, right? 21.8 degrees below the horizontal. That is the what? The direction. So I want to believe that you enjoyed this video. Please don't be stingy. Share so that your friends can also enjoy. And do well to subscribe so as to get notifications when our video drop. Thank you for joining us. See you in the next class.